Hello, everybody. So my thank you to the organizers. We have been here on the workshop and learned a lot. And this is also something that shows our dedication to analytical ultracentrifugation, that we always try to at least understand what you guys are doing here. Advanced characterization using the AUC. And so it's something that we are doing actually, we will do in the future. So your characterization technique is very important to us. I'm not giving a scientific talk here, I'm giving a talk about our dedication. You will see some nice pictures here and also understand the situation of AUC and Beckman in the future. We have a second talk here on the meeting that is a more scientific talk, and I hope that you're all looking forward to then hear Amy presenting. So my talk is also about a personal perspective on the history of our engagement in AUC. There's a little bit a disclaimer here about the property. And personal perspective, I added to the title because there is not a real good description of the history of AUC available. Maybe it's something that one of you picks up one day and writes a comprehensive summary on about the history of AUC. I think it's something that is missing. So we several years ago created a video about the history of AUC. This is available on YouTube. It is a video that you could look into and maybe you find it exciting. I added a slide here to start with a funny note. Yeah, so we presented on the history of AUC there on YouTube, and there was a feedback on YouTube, social media. And the feedback says, this gives absolutely zero information about AUC history. We already know the timeline of world history and molecular biology in general. Your job was specific for AUC. Yeah? So, a good statement. Yeah? The statement was done by a person, yeah, who calls himself the sexy scientist. And if the sexy scientist is present here, maybe he can help us understand the comment. Yeah? Okay. Good. So there are more reasons why I named it personal perspective. You will also see in some minutes what is my personal entry in AUC here. Of course, we have 80 different AUC users here, and so we will have 80 different points of view. But what is important to me is the technique is often overlooked, and we need to have the engagement of the companies that are involved in that, and of all of you scientists to be enthusiastic about the technique, to communicate about it, and to tell your story about AUC. My personal journey started with this book here. It's called Physics That Relates to Us, and I got this from my parents when I was 11 years old. Yeah? Then I went into studying physics and slipped into the field of biophysics, was working on membrane transport, and this also brought me then to the use of AUC. I got in contact with Beckman at that time, and I'm an employee since 1996, so AUC was also very important for my life and for the life of my family, of my children, and I think it's the same for a lot of you here in the audience. Beckman was not involved in everything that was happening before 1947, yeah, so there had been Theodor Svedberg, you know, all that. These are pictures from the Svedberg lab from a meeting we had in Uppsala. Then Theodor Svedberg got the Nobel Prize in 1926, so I think we are looking forward to more promotion of the technique also in the coming years. And the LAM equation has been developed in 1930. And ultracentrifugation before the commercial availability of instruments was a quite tough job. Yeah, so it says it had been running the instrument in sub-basement behind 3-foot thick walls of reinforced concrete, and required constant attention, a willingness to spend most of your time flat on your back in a puddle of oil. Yeah, with the Model E, it was more mercury that was on the floor. Yeah, so okay, but anyway, moving forward, Beckman did not start with ultracentrifugation, but Beckman started producing ink for the National Post in America, and after that he developed the pH meter. Then he developed the spectrophotometer, which also helped to understand how to build optical systems into centrifuges. Also, AUC was not started by Beckman Coulter. Yeah, it was started by a company, Spinco, here. And this company developed the Model E centrifuge. And they tried to commercialize it. They had not been very successful with that, so almost went bankrupt, and then they sought guidance from Beckman. He was a good businessman as well, and that led to the integration of Spinco into Beckman, and since we call this the Spinco division in Beckman Coulter. Beckman always rated analytical ultracentrifugation as a very important technique. So he said it was the most significant innovation in the development of life sciences. So you're all working on a very important field, and it is still the best technique to understand what happens in solution to these macromolecules that are typical for living systems. I had the question also coming up here, why is it not more visible or whatever? And a lot of you guys know that, but the younger guys probably do not know that. So there had not been many instruments being developed in the time that AUC is available as a commercial product. Yeah? The Model E was available for a long time, but then the main application at that time had been replaced by SDS gel electrophoresis when this was developed. Because of that, we have this red time where there was no analytical ultracentrifuge available. And some of you call it the dark ages, some of you call it the lost years. But this, we understand, is the reason why AUC is still a little bit underrepresented in the characterization techniques. So there was the Model E. This is the old brochure of the Model E. I have some historic documents also on our booth. And then there was the XLA that somehow brought AUC into the modern ages here. And I will show you that in these dark years, also Beckman was developing solutions for analytical ultracentrifugation, and it was not lost years, but it's all in the products we're selling today. So also, I want to point that we are doing support as long as we can do support for the instruments. I will come to the support situation for the XLA a little bit later. And we're always also advancing the technique. So after the analytical ultracentrifuge, the development of preparative instruments started, and this brought a lot of technology improvements also to analytical ultracentrifugation. So with the preparative centrifugation, we started looking more into the temperature control of the samples than it was with the analytical ultracentrifuge at that time. And we also improved things like how to lock the rotor to the instrument and drive technology. In 1960, we introduced improved vacuum systems that are also very important for what we're doing with the AUCs today. And also the temperature readout, and this also brought us to try to control the temperature of the samples better than was possible before. This is something that today gets more and more important as the instruments get more and more precise. But then there was also analytical instruments in these dark years. In 1966, in the L2 series, we added an optical system to a preparative ultracentrifuge, which finally is important for the instruments we are doing today. Yeah? So this was the start of that. It was a Schlieren optics system, and this work was continued over the years. This is a nice picture, and I have these instructions for use at the booth. So the instructions for use even included models you could build to understand the optical systems of your centrifuge at that time. We did more optical works for the centrifuges. This is a photoelectric scanner that was used for rock core centrifugation. So basically where we measured how much oil is in rock cores. Yeah, so also very important. I would like to stop this running so fast. And in the 1970s, we had the first photoelectric scanner on a preparative ultracentrifuge. Yeah. That was a UV-Vis scanner, and it already had a readout. That was not the pin printer of the Model E, but it was pen-drawn documentation of data. Yeah? So interestingly, at that time, still the Model E was the most used analytical centrifuge. So at that time, the community didn't really pick it up, the innovation of the developments that Beckman made. Then in 1989, we introduced the Optima technology. That is still a lot of the technology that is in the Optima AUC today. So it is including thermoelectric cooling, an air-cooled drive. Go back here. A rotor safety check. And this is also something that is often, you don't even know that you have it. It's a moisture purging vacuum system that works, that makes the vacuum system more reliable and helps you to use the instrument also in humid times and in summer. The base unit of the instrument we're using today is the Optima X series. So with this, we introduced a computer as a control unit of the instrument. We have a lot of new technology in that instrument. Basically, this was launched with 8 patent applications at the time it came out. Regarding the analytical centrifuges, so in 1991, we introduced these XLA. Interesting, there was an article here by Schachmann who developed the first analytical ultracentrifuge. And you all still know that system. A lot of you are still using it. So we have this optical system they have to build into the centrifuge before each run, take it out. And the system then was improved to the Proteome Lab XLA, XLI in 2003. And okay. There's still a lot of these instruments in use. So in England, Steve Harden has the serial number 1. I worked in an institute that got one of the first instruments that came to continental Europe. And BASF was another customer at that time. And we worked together with the BASF to validate the XLA centrifuge. At that time, I was in the institute, but I was not involved in AUC. But this discussion about that instrument, for me as a physicist, had been very exciting, and I very much appreciated the work with Walter Mechtle. Yeah? And he influenced me to step into analytical ultracentrifugation as a technique. And I think a lot of you still remember him. He was a very smart guy. Yeah? Good. Now coming back to the book that brought me to study physics. And if you look at that closer, this book was written by Walter Mechtle. And I found out just after he passed away. So, but isn't that a crazy story? Yeah? Okay. So my story is influenced by that book. Finally, I was drawn into that field. I was drawn into the community, a very nice community. And so it had a big influence on my life. And so I think all of you have these kind of stories, and it's important. Yeah. Now I'm coming to a difficult slide. Yeah, so this is about what happens now or in the near future about the XLA, XLI centrifuges. Yeah? There had been letters being sent out. I know that not all of you have received the letters because it's difficult to send letters to people who are not under service contract. The XLA, the XLI, and the Proteome Lab XLA, XLI will not be serviced from Beckman after the end of 2025. Yeah? And it's something that is also very difficult for us. We understand it's difficult for all of you. And I also want to use this meeting to get in contact with you, understanding the situation you're in, to wherever it's possible, handle that in a way that supports the transition to the new technology. But you see the time frame. So we are servicing this instrument for a long, long time. We have a new technology in place, but we understand it's difficult to transition to that new technology because it's an investment for all of you, and we understand that funding situations are difficult and these things. So get in contact with us, speak with us here or with your local contacts, and we will try to find good solutions for that transition. Active, obsolete, and discontinued. So I have a slide on that. So the instrument's obsolescence date was when the Optima AUC was launched, means that we are not selling the instrument anymore. Yeah? Discontinuous means that our service cannot service it anymore, and we cannot offer service. So this is because of capabilities. It's about, with the XLA, XLI, about parts availability, but it's also because of compliance. And we, as an organization, also have limited flexibility there. Yeah, so this is an unfortunate situation. In the time between obsolescence and discontinuance, we typically offer best effort support. Yeah? And this is what we also do with the XLA, XLI until it's discontinued. The future of AUC from Beckman Coulter is the Optima AUC. We have an instrument here. Alexander mentioned that, so I also put multi-wavelength capabilities at the top priority, so it will also improve your science significantly. Yeah? The instrument is a modern platform, so has a different operating system that is on a modern basis here, Linux-based interface, user interface. For users, especially for beginners, it's very comfortable to use the optical systems because you do not have to handle these optical systems anymore. So I think a big improvement. And also the quality of the data improved. I had a discussion with Ute, so I agree that maybe not for a single scan, it's necessarily a significant improvement, but because we can do so many more scans with the scan speed, the complete data you get from an experiment gives you better results for your science. Yeah? So you will improve your science by moving to that platform. Yeah? The instrument at the beginning had temperature issues, and a year after the launch of the Optima AUC, we improved that by redesigning the shroud of the centrifuge. So we introduced this narrow thermal shroud. We introduced heat shields so that we say today the temperature control of the rotor in the Optima AUC is good enough for your science. Yeah? I know there are some publications that say under specific conditions, I would still like to have a better temperature control, but basically these improvements here brought the instrument on a state where it's working according to your needs. And with this, I close my presentation. So thank you.